again a welcome to each and every one of you for participating in this panel discussion, which is being organized by ISHRAE Technical Committee. This is one such sixth program in this series, that is the panel discussion online series that is organized by ISHRAE Technical Committee. So this is one online panel discussion on the topic, very interesting topic, which is HVAC system selection and applications of larger HVAC plants for system optimization and energy efficiency. So this is the very interesting topic today, and we have with us all the eminent people with us online, connecting to all the people, and still we are approximately around 120 people just starting in the very first 5 minutes of this panel discussion online. So we have with us our society president-elect, Mr. Jayanta Kumar Das from Kolkata. We have with us Mr. Nishan Gupta, who is the society chair for ISHRAE Technical Committee. We have with us our moderator for this panel discussion, Mr. Vishal Kapoor, who is from Kolkata, and he will be working as moderator for this panel discussion today. And we have with us all the panelists, eminent panelists from various regions and various professional lines, various domains, as an HVAC consultant, HVAC manufacturer, HVAC end user, and HVAC contractor. So Mr. C. Subramaniam from Bangalore, he is the owner of Messrs. Triple S Consultant and 3S Green. As the HVAC consultant, he will be sharing his thoughts as HVAC consultant in the panel discussion today. Mr. Dheeraj Vadwa, who is from Messrs. Carrier India, who will be representing one of the chiller manufacturing company as HVAC manufacturer in this panel discussion. We have with us Mr. Azaz Qazi, who is working as MEP head at Messrs. Reliance Industries Limited from Mumbai as HVAC end user, and Mr. B. Kalyan from Hyderabad. He is the owner of Messrs. Siri Comforts and will be representing as a HVAC contracting firm. So this is the complete panel today, and the topic is again unique, and all the audience, definitely we all looking forward to a great information will be spreading during the panel discussion today. So before starting, I would like to invite Mr. Nishan Gupta, who is the society chair for ISHRAE Technical Committee, who will be sharing his thought from the ISHRAE Technical Committee point of view. Sir.
Thank you, Mani. I hope I'm audible.
Yes, sir, you are audible.
Thanks. So, good evening, everyone. And first of all, thank you, Mani, for organizing this wonderful session, a great topic. As we all witness, India is in a booming stage. Being in the construction industry, all of us can agree with the smart city mission government is posing now. Lot of new construction projects going on, lot of infrastructure project going on. The scale of the project had been continuously increasing. We all believe that in times to come, the amount of construction which has been done so far will be almost double in next 8 to 10 years. And professionals like us have to upgrade, upskill ourselves. There are various concepts when you talk of large application. There are cases when we see inverter driven VRF systems being used for large areas, central air conditioning systems with modern technologies like primary pumping, distribution pumping systems are getting involved. A lot of IoT based controls are being used. Now, each system comes with its own challenges and benefits. For us at society level, we are being part of the decarbonizing theme. We all are volunteers of decarbonization. It is important for us to understand the challenges, the possible solutions, and hear from the best of the minds. So we have a very decorated panel, and I'm sure Mr. Vishal Kapoor is going to make it much more interesting with all the dignitaries who are present as a panelist. I'm sure that you all would learn, and we really look forward to a great session. So once again, thanks from ISHRAE Technical Committee. I would request all those who are still not part of any technical groups would please come forward, seek your interest, start contributing by joining the groups, contributing in terms of your knowledge sharing, as well as at the same time, learn from whatever latest is happening. So wishing the team a very interactive and very informative sessions. And thank you once again. Over to Mr. Vishal Kapoor.
Thank you, sir. Thank you. Thank you for your words. So now I would like to invite Mr. Janta Kumar Das, who is the society president-elect for this year and will be the president for the next year, definitely. And yes, we would like to hear from you how ISHRAE as a society are looking forward to integrate all industry professional, HVACR and building industry professional to work with ISHRAE and how ISHRAE is moving towards research and standards. Sir, please.
Good afternoon.
Good
Am I
afternoon.
audible?
Yes, sir.
Yeah. Good afternoon to all. On behalf of ISHRAE, I would like to welcome you all for this panel discussion. I would not go into the panel discussion topics, which you have already heard about it, and we have very knowledgeable panelists, and the discussion will be done by moderator Vishal Kapoor, who is a presidential member of ISHRAE and had moderated many discussions in the past. As far as ISHRAE is concerned, ISHRAE has a footprint of chapters through 59 chapters, sub-chapters in pan India as well as in international locations. ISHRAE, we all know, is basically knowledge distribution is our main goal, and we have been working towards that through technical committees, through research committees. Now ISHRAE has been working with the government departments also. We are working with BIS for the new standards which are coming up. We are working with BE also for the updation of different initiatives which government is taking. So through all these activities, ISHRAE is moving forward, both at the serving the members as well as to the nations also. And with the international reach, we have now chapters in UAE, in Qatar, in Bahrain, and other locations in Nepal. So through these locations, we are reaching to the international locations also, and ISHRAE is really going global. And with this type of initiative, which I would like to thank Nishant and the entire technical team who has taken this initiative for this type of webinar, which will help us to reach ISHRAE's technical knowledge dissemination to each and every corner of India as well as international locations. With this, I would like to hand it over to Moni Khanna to take this event forward. Thank you.
Sir, thank you for sharing your wisdom for the society and how we are working towards it. So now we will not take much of the time because it's a very interesting panel discussion today. So I would like to introduce Mr. Vishal Kapoor, who is the moderator today for this panel discussion, who is the partner at Messrs. Meho HCP Air Systems. He is from Kolkata. He is the presidential member of ISHRAE, and he is also the society chair for the skill development activities in ISHRAE, and he is also the past society chair for ISHRAE Advocacy Committee as well. So everyone knows him personally and professionally. He needs no more introduction. So we will not take much of the time, and we need to start this panel discussion today. So over to you, Vishal sir, please.
Thank you, Mani. Thank you, Nishant. Thank you, JKD. Thank you for introduction remarks about ISHRAE Technical Committee and the seminar today. Could I have all the panelists put their video on, please? Dheeraj, Mr. Kalyan. Yeah, thank you. So as you've already been briefed about today's topic, and it's a very interesting topic, as we all know, and Nishant talked about where India is and where it's supposed to go. And the famous phrase is that half of India is yet to be built. And that's how we're seeing it built right now. But when we talk of today's subject, and I wanted to limit ourselves to 3 key areas because of which the plant sizes are increasing and are going to go and become bigger and bigger in the days ahead. Number 1 is infrastructure. And we know that the present government's efforts and aims on growing India's infrastructure across all applications, from airports to ports and everything possible, is mega. It's reaching out to the smaller cities, to larger locations, expanding airports everywhere. That's one big area, one big reason why we have this kind of development happening. The second is industrialization. And we know manufacturing is a big focus area again. Make in India, a lot of import replacements. You look at chip market manufacturing is starting in a big time in India, solar plants, The list is endless. Data centers, I'm putting that on the industry side only. And we're seeing the size of plants that are coming up now are mega. A few years back, talking of 1,000 plus 2,000 ton jobs used to be a few here and there. And now every day you're hearing jobs are 10,000 tons and 12,000 tons and 20,000 tons and all those things coming in. And the third concept that is coming in is on urbanization. And we know that more than 20% of people are actually either moving to urban centers every year, or where they are actually getting urbanized, a mix of two. So urbanization again will make it necessary to have mixed use developments coming up. Today you have a lot of projects coming up in India, which is a combination of residential and hotels and malls and hospitals all coming together in one township, both in larger and smaller cities. So these three for me, could be many other reasons, but these three for me are the key reasons why the capacity of plants is now becoming bigger and bigger. The other reason, which is not from an application point of view, is obviously on an efficiency point of view. How do we ensure that we need more? There's no doubt that this country needs much more air conditioning in the years ahead. But how do we ensure that our power bills, our carbon footprint does not grow at the same speed, actually degrows? Carbon has to degrow, and energy also does not grow at the same pace as air conditioning. Otherwise, it's going to be difficult to be able to generate that kind of power. So a lot is happening on that front also to ensure that, yes, we need more air conditioning, but at the same time, we are actually in the footprint reducing and not increasing our power consumption, our power requirements. So when we were deciding on today's panel and we thought, how do we get a mix of the right people to talk about? Before choosing the personalities, we thought, let's be able to cover all the four facets of a large or any HVAC installation. And you obviously start from the designer, the consultant, and we have our dear friend Subbu. I'm going to be calling him Subbu. Obviously, you all know him as Subbu, also a presidential member of ISHRAE. In fact, he was the president-elect, now the president, so we're good friends. Subbu will represent he wears actually two hats, as an HVAC consultant and also as a BMS specialist. So he's here representing that facet of the whole spectrum. We have Mr. Dheeraj Vadva, who's director with Carrier, and he represents Carrier air conditioning from as a chiller manufacturer. We know Carrier has been is called the father of air conditioning, the inventor of air conditioning, and have always been at the forefront of innovations, new products, new technologies. So we're going to be hearing from him all about what's happening in that sector and how are the manufacturers keeping pace and the technology development that's going ahead. Then we have, obviously, both Subbu and Dheeraj won't have jobs if you don't have an end user. And you need an end user, you have Ijaz Kazi, again, a dear friend. He's with Reliance and one of the biggest buyers of air conditioning in the country. One of the people who are, I think, if I'm not wrong, in all those three spheres, from infrastructure to urbanization to industrializations, engaged in all spheres in totality. So he's going to be talking to us from a user point of view, from a client perspective as to what happens. And needless to say, I'm a contractor. The contractor comes always in the end. But the most important part of the entire chain, we have Kalyan. Kalyan is from Sri Comforts Deccan, Hyderabad, works all over South and other parts of the country. A big chiller, central plant integrator, contractor, both VRF, chillers, everything. He comes with a lot of knowledge on actual on-ground realities of what is happening out there, not just at the time of design and installation, but obviously going ahead from there also. So that is how we've kind of tried to get a mix of the entire spectrum to ensure that we're able to cover as much as possible. We have around 1 hour today from now onwards to see as best as what we can contribute for all the delegates listening in today and also for all of us out here. And I'd request each panelist to, kinds of try and see if they can limit their first responses to 3-4 minutes so that we can cover more and more questions. To the audience out there, if you want me to ask any specific question, please feel free to add this in the chat. I'll try and see during the course of the discussion or at the end if we can pick up some of those points, questions, and ask our esteemed panelists. I'm going to start straight on with you, Subbu. And you, amongst the four people, the four spectrums, is the first person who comes on board when a project is being designed. Envisaged at times, it's not even broken ground when the client, the architect, get a HVAC consultant on board. Now, at that stage, what factors are considered specifically from a large commercial or a large industrial buildings when you're selecting an HVAC system? That what kind of a system you want to propose to those clients and architects? What are the key factors that you take into consideration?
Yeah, good afternoon, everyone. It's nice to be part of this very important discussion, which contributes to almost 50 to 60% of energy consumption in building. And this plays a very great role in that. See, ideally, as you said, we have to have a very good first interaction with the owner, trying to understand from him what kind of application, what kind of building application and purpose of the building that he is going to have. That is very, very important to begin with. Now, is it going to be tenanted building? Is it going to be owner-occupied building? Is it going to be mixed-use building with all the facilities and all that? And also, possibly we need to look at, from other point of view like healthcare, hospitality, industrial, pharma, clean room, or commercial office space. What is that? And if it is going to be a campus kind of a thing, is it going to be on all this, or does he have plans to expand to other kind of requirements? Then, from an industrial point of view, we again have to understand the process requirement, cooling, possibly heating, and do we have simultaneous cooling and heating happening, for example, in some hospitals, in hotels, and things like that. And location of the facility again, and availability. Since we are talking about large systems, we have to talk about availability of water and possibly quality of water. How good that water can be used, or if not good, whether can we treat the water, because that plays a great role in initial selection of equipment as well as the operating challenges which we have. And the thermal load flexibility of the facility, and what we have to do is we also have to understand the calculation which we need to do during the occupancy period as well as the year round, because that plays a greater role. For example, we just get, let's say 6,000 tons or 4,000 tons or whatever it is, or larger. It's not that we just have to divide by 4 or 5 and then break down the chillers. It all depends on the building load profile and what we are trying to have and things like that. And owner occupied, again tenanted, that is, we have multiple buildings. Then again, the economics is very important. Now, how the economics plays a very important role is the first cost, the operating cost, maintenance cost, because the owner is going to pay the bills every day, every month of the year. And return on investment, what he is talking about. And what are the demand tariffs that we have during the day and night? Do we have differential tariff? Because that will give us opportunity possibly to use thermal energy storage and things like that to reduce our total cost of ownership and see how we can reduce the operating cost. And again, the environmental aspects and what are the things that the customer would like to have, temperature, RH requirements, cleanliness levels, acoustics again, how important it plays a role, then control aspects, the nature of thermal load again in the building, whether what is the mix of sensible and latent load, be it a process or be it industrial process, or again your hospitals or clean room and other applications, because that will define what kind of fluid that we need to use in our HVAC system as such. And is it kind of existing facility, new facility, redundancy again, and reliability of operation. Spatial requirement, do we have flexibility of various options, or do we have any architectural site restrictions and constraints? And also we have to have a good discussion with owner on scalability, expansion of capacity. What is it that he has in future? Is he planning to just have one facility built in the campus or on the building, or is he or she wanting to expand the facility? And again, delivery of the project timeline phase wise, we would like to know, because depending on that, we have to also see. That is again there. And the system integration of the facility with other infrastructure of the building, other MEP systems of the building, that is very critical. How important it is to function along. And again, based on all this, we have to possibly look at making a matrix of giving various factors, various weightages to various factors, and possibly looking at option 1, 2, 3, how do we weigh these options. And while we do this, the most important aspect is again system efficiencies and various options. And we also have to understand from the customer on his or her sustainability goals. What do they want to go for in the next immediate current requirement? Do they have any sustainability goals how far they want to go on sustainability. For example, any rating system you take, IGBC or LEED or GRIHA, what level of certification they want to do, what kind of environmental responsibility they want to take, and also what is their approach 5 years hence down the line, 10 years down the line on the net zero, because we have got so many other things coming up. So it's quite so based on this, all these factors, we have to look at, breaking it up into high side, low side. How do we handle this? What are the various options that we can put in front of the customer? And as a team working together with the architect and the other design engineers also, holistically how HVAC system is going to work as a very high performance earthwise system in this whole gambit of things. I think that's what in summary we would like to put in there.
Yeah, I know it was difficult to summarize because it's not an easy job that as a consultant you're doing. A lot of people don't understand. They think it's just a tender that comes out and the amount of time and effort that's put behind. Because you just summarize this in 3-4 minutes, what actually would take you a few months to be able to put through. But thank you, Subbu, for sharing, in brief as to what really are the main key points. I picked a few words, few specific points from your answer. One, talking about scalability. You were talking about large campuses, and I want to reach out to Dheeraj, going from you, jumping straight to Dheeraj as a manufacturer. Dheeraj, let's talk about two aspects over here. One is about scalability, and today we know that a lot of clients are wanting to have systems which are scalable in future, short term or long term, and the other is about distributed HVAC systems. Now, both from an actual installation basis, how does scalability work? And how do we ensure that it is available in all these designs? And also from a distributed HVAC system or a district cooling system in larger plants, what is the impact coming on energy efficiency today?
Thank you, Vishal, first of all, having me in this elite panel. Okay, I am one of those persons who probably have the least gray hair amongst all of them. So the experience, what everyone else carries today is much more than what I have. But being a part of this panel, let me just share my experience, what I have with me. And it's a very interesting question, frankly. And I'll have to start with where actually Subbu picked it up from. What happens is when we design any system and we have to have certain objectives in front of us. Subbu very nicely put it up, with respect to whether it is a campus or whether it is a different application, technology. But most important is what does the client want also has to be kept in front. That's the biggest challenge Subbu and other designers have in front of them. They may look at economics, they may look at power consumption, they may look at carbon footprint, they may look at space constraint, and it can be any and many, frankly speaking. So most important piece, what comes as a natural answer for us is, if you're looking at scalability, first look at the load variability. So for that, you do have the weather data in place today, luckily for us, across the complete geographies globally. If you look at the weather data and then plot what you require as an application in your region, and then look at what is the maximum load you have today, what is the minimum load you have today, what is it that you expect in times to come, how is the weather going to change over next 5, 10, 15 years, what is the prediction kinds. So all these things, when taken into aspect, it helps us in having a futuristic approach as well, and not having just an immediate approach. Basis that you are able to have a design in front of you, which is the best possible design, and then you can have a distribution of that load across what kind of equipment you want. I would not like to restrict myself to only chill water systems. You got DX type systems. So another challenge what designers have today is which system should I pick up from? And frankly speaking, I don't have anything against them, but rather, if I may use the word, I actually sometimes pity them, because you've got 10, 15 manufacturers, you've got at least 20, 30 type of technologies available with you. They cannot reach out to every manufacturer for every technology to be known to them. So they pick up few of them, and that's what the challenge is for them. Now, coming back, once you design a system, the scalability has to be basis the application, basis equipment, basis futuristic needs, what you anticipate and expect, what you see as a weather condition changes that's going to happen, occupancy, everything put in place. Now, once you do that, what it does to the system, not only from an efficiency aspect, but immediate aspect is any user would like to see that how can I balance between my capital cost as well as operating cost. So once you do a perfect design on distribution of load and selection of equipment, you are not only able to bring down the capital cost, but you are able to also look at how do I optimize my operating cost for future. And my plant to become scalable in such a way that I'm trying to use similar kind of equipments. I'm trying to keep variations as low as possible, whichever equipment you pick up. For example, I'm just taking an example for that matter. If my load requirement is 10,000 tons, can I do with 1,500 into something? Can I do with 2,000 into something? Can I keep just two options so that my space requirement also reduces accordingly? My futuristic need also gets optimized accordingly. And this helps you not only maintaining the plant, but having an operating cost. My point where I would like to say district cooling that way is probably one of the best things to happen, because what it brings in front of us is, if I may pick some of the applications for having a better understanding, airports is one of the example, campuses is another example, pharma parks, industrial parks. These are the applications wherein you can have probably a private-public partnership, government focus in development of these parks. Why don't we look at having some auction kind of an arrangement wherein we've got private developers taking up this as an ownership, and there's a public-private partnership. You develop that complete pharma park with only single air conditioning plant, which is district cooling. What it does, larger the capacity of plant, larger the diversity you have. The larger the diversity you get, the peak load comes down. As soon as the peak load comes down, the connected load requirement comes down. See the benefits. And the more diverse the application is, you are able to get a more optimized plant under part load conditions. That is where your plants work the best. So that's a benefit which is linked to the design, and district cooling is the best example. Today with India growing so fast, all applications across, this is the best opportunity for us to try and see how much of district cooling design can we adopt. And that's where I would like to end, Vishal. You're muted, Vishal.
Yeah, thanks, Dheeraj. You hit a nail on the head when you talked about district cooling and it gaining a lot of traction now in India, though still, I don't know, in my limited knowledge, very, very early days. There are a lot of regulations that need to come in from the government, both financial support, regulation support that needs to come in from the government, funding support that needs to come in, because these are all mega plants. That's when it becomes more viable. And in this context, I'll want to reach out to Ijaz. Ijaz, you're representing Reliance over here, as we said, one of the biggest users of HVAC in the country today across all segments. And are you seeing district cooling concept gaining acceptance? Is there any key challenges that you are seeing today in the field out there for taking up district cooling projects?
Yeah, thank you, Vishal. Thank you for having me here. So yes, it is gaining acceptance, but the progress is very slow. I think last week we have heard one news that one of the giant Tata Power has joined hand with Keppel, again the giant of district cooling, of Singapore. But the progress is slow. Yes, as Dheeraj said, with the rapid urbanization where the India is yet to be built, as everybody is saying, half of the India is to be built. I think it is more than that. Plus the rising temperatures, the peak load, issues, the smart city initiatives. Every corporate has now the ESG goals. I think this should be taking a big momentum. But I think challenges are there, and I think there are four challenges. First challenge I believe is the awareness. There are a lot of skepticism about the potential benefit of the district cooling. Now I will give an example. When we build malls or when we lease out any of the office building, and when we put a BTU meter, people have a doubt on the BTU meter. And I can see when I was in earlier role, I have seen so many disputes between the leasee and the developer, having the dispute about whether the BTU meter is right, are there any fudging, or those kind of. I think these are major issues which are again will come back to this benefit of district cooling, because people will have the doubt on the measurements. And how do we do that? I think ISHRAE has to drive this, and ISHRAE is driving to make sure that yes, these doubts are cleaned out of the mind. And when you talk about major builders or major developers, many people are jumping in. The doubts have to be cleared. Otherwise, this will have a stoppage. Second thing is implementation. Now I can see where I'm coming from. Mumbai, you must be saying BKC. The best thing, a district cooling plant can be done in BKC. But challenge is again the implementation. So many stakeholders, including a lot of corporates, a lot of government, buildings there. But how do we implement is a bigger challenge. The third important aspect is financing model. I think, yes, government is pushing, but I think a lot of thrust from government, from the policy framework perspective, it is required to push further, because the advantages are so many, but we need to again work with government to see that it is pushed. Maybe some financing models can come up. Some of the companies have tried, as I understand earlier, to have some financing models. But again, the issue is whether that payback will come, the money will come back or no, is again a doubt. The fourth important aspect, now I'm not talking about cities like in Mumbai, but there are challenges about what uninterrupted water and power, which is again a major thing, which is now, yes, the power is reaching to the every places, but again, that could be another reason or challenge for having district cooling. So I think these are four things which I thought coming in mind about the district cooling.
Is Reliance planning and doing a lot of district cooling applications?
We are doing in our own campuses, because if you look at even Geo World Center is a mini district cooling. It's a 12,000 ton plant and it's a mixed use building, but it's a mini this thing. Like we are doing now, the renewables plants in Jamnagar. We are working with those are not so called as a green the district cooling, but yes, we can say mini district cooling plants which are being done.
Thanks, Ijaz. And yeah, it's good to hear. And you shared 4 points that are kinds of challenges in the current date for district cooling. But I'm pretty sure that everybody, industry, the associations like ISHRAE, the government is all working to kinds of get over that whole trend. And we're going to be talking of some numbers, maybe down the panel discussion as to some case study if somebody wants to talk about, what were the kind of savings compared to our standard system converting to a district cooling. But before that, I'll reach out to Kalyan, and I want to just totally change the topic all around. And this is coming in more from a lot of questions that are coming in from the audience today. Kalyan, is that, still today, and Dheeraj also touched about it briefly when he was talking about, is why just chillers? Why just keep on talking only about chillers? Today, we're seeing huge, large mega installations happening with VRF systems or DX kind of applications. And there are questions that have come in, even in the audience has shared some questions. How do you choose? Subbu has tried to answer that, Dheeraj has tried to answer that, but yet we go out there in the place and we see two buildings, similar kind of buildings, similar orientation, similar applications, and one has been designed with large water-cooled system, chiller systems, and the other has been designed with VRF, and both are working fine. How does a contracting company, because you're not just contracting, a lot of jobs come to you as design build jobs also, or retrofits. A lot of jobs come to you as retrofits. Where is this modular or VRF DX versus chiller fight, if I may use the word, going ahead today?
Good evening, everyone. Thank you, Vishal, for the great opportunity to be in the panel and also the technical committee of ISHRAE. It's a great topic. And you asked me the toughest question in the whole thing. Like, it is very difficult to say which one is good or which one is bad. But at the same time, what we find is we do chiller project as well as the VRF projects in a same campus, or maybe at same campus, one university campus, we have got a chiller as well as VRF, working simultaneously. But the issue is, the application actually. It is for a big office area where you have 4,000, 5,000 tons of chilled water requirements are there. Definitely people go for chiller without talking anything. The same thing what we are doing for some of the apartment building, where the number of apartments are around 300, 400 apartments connected to different thing. There were apartments connected to chilled water, but the issue is, many things. Like one is, the metering. Who is going to meter the chilled water? That is number one. I am not using, you are not using, and what is the maintenance cost, what you are going to pay, who is going to pay for the maintenance, who is going to take care of once the apartment building is done, 2 years, 3 years, the builder maintains the building, then it goes to the society. Whether society has got a knowledge to maintain the chiller, and who is going to take care of the chiller, what and all they have to do, whether if it is a water-cooled system, whether who is going to maintain the cooling tower, these kind of issues are there. In that cases, they find it very simple. Why don't you put a VRF? I'm going to go directly and go with the AMC with the company. Whether I give AMC or not, I myself clean the filter and clean the coils and, keep my air conditioner intact. These kind of thinkings are there. But at the same time, one more important issue, what we find is today the skilling and the availability of employees, availability of manpower. That is going to be the biggest thing in the total industry together. And I'm not talking about VRF or I'm not talking about chiller. If it is a chiller, definitely if it is a district cooling system, where for a particular township, if you are going to give, then it is definitely the chiller is the best system available in terms of power, in terms of the connected load capacity, in terms of retrofit, in terms of space occupancy, everything. It is not going to occupy many things. But in a 500 or 400 apartment, how this guy is going to maintain the whole chiller. Like let us say if he is going to maintain a 3,000, 4,000 tons of chiller, whether the association is capable of handling the chiller and maintaining the chiller over a period of time. But again, the life expectancy, like, in any chiller, it can work even for 15, 20 years easily, whereas the VRF goes up to 10, 12 years. Then you started getting spare parts not available. These kind of things are there. So, it is a balanced view. We have to really look at my simple submission in this case is, if it is a smaller apartment up to 2,000, 3,000 tons, it is better to go for a VRF and, have an independent VRF for each flat and, go with the flat. If it is a residential application, definitely for a commercial application, the chiller is the better bet because, people are there, technical people are there. There is going to be a maintenance oriented people are there to maintain the system and all that, but definitely not in the residential case. And of course, as Mr. Subbu said, we need to really look at what is the real application and what is the real loads, which are their peak loads and other things. And district cooling plant is something which is going to take over the period of time. As you said, the knowledge levels are very low. In fact, I had a opportunity to see the district cooling 12 years back in Dubai, in financial district, where 40,000 tons of district cooling is connected. 40,000 tons are connected in a ring main and, supplying to the financial district. That is more for a, commercial purpose than the residential purpose. But, over a period of time, district cooling is going to take, but in the recent times, VRF is going to dominate in the next 15, 20 years. Being in Hyderabad, we have large buildings coming up for the residential as well as commercial places. Most of the residential places, we have up to 60 floors, 40 floors, 45 floors. All are designed with VRF. We had one or two, buildings we had with the chilled water system where the installation was very poor. Because of the installation was poor, that project failed and people started going towards the VRF system. This is another issue. That's why I said the manpower and skilling is very, very important. It is not the application or anything, but in a residential place where if the water is leaking and if you don't get, temperature of 18, 19 degrees, people are not satisfied at the residential level. So the chilled water will take a longer time to reach a residential apartment, rather the VRF has already reached. And, there are at least 15 projects, bigger projects of 5,000 to 10,000 tons are working in, the work is going on in Hyderabad. This is my submission.
Thanks, Kalyan. And very rightly, you talked not just about the first installation, but over what happens down the line over a few years. And you talked about a lot of cases where, and I'm going to ask this question to Subbu as a follow-up, is very briefly, do you at times select designs with multiple options and present it to a client, specifically where you have a DX versus chiller kind of an options available, any kind of an application? Do you do that, or is it you who takes a call finally on which equipment sets in best? Or do you actually give some examples and comparison of define technology A, technology B, this is the whole way it comes out?
I think, Vishal, what it really happens is depending on that, whatever range of tonnage application we are talking about. If you have something between 500 tons and 700 tons and all that, and the application wise, then you can possibly look at different options and telling the customer, yes, these are the options available. But when you go for really large systems, you're talking about 3, 4, 5,000, 10,000, 6,000, then you don't really, you don't have that much of an option was a VRF versus a chilled water system. So generally you go with chilled water, but within the chilled water itself, you will have various options. You may have option of using a hybrid of air cold, water cold, possibly thermal energy storage and things like that. Those kind of applications. Options will be there. But really, you know, given a project like this is a hotel project, but even some of the hotel projects, you know, maybe they wouldn't want to go into the VR of A because we know, yes, there is a ease of so many aspects, but on the other side of it also, you know, you also have to look at what in case something fails, what in case something happens, what is the impact of that on the owner's cash flow and kind of reliability of the system and all. So we have to look into the complete aspect of the whole system. And on that, some of the quick points on the district cooling system, I think what we may have to do when we have complete faith in the electrical energy meters, I think we have calibrated and metered the BTU meters. I think faith has to come. And it is a question of, I think, the entire industry rising up to the challenge, and you know, the trust kind of thing from the end user and owner and tenants, who will say that yes, this is a BTU meter. This is the thing which is possibly we don't have any BTU meter manufacturer in India. Most of it comes from Europe. So you have a calibrated. There is a European standard to it and things like that, and that is how it works. So the only thing is, the owners have to be really told that if they want to maintain a system, they will have to definitely park some fund from their, you know, revenue and put it there, park it there. I'm sure Ajaz will have a lot of answers, and Reliance is one of the very responsible owner in this in our country, so that's different. But not many are there like that, where you know they just, and owners. What I do find is, even I find some owners who build, you know, at the end of the day, over a period of 5 years to 7-8 years, they have 10 to 15 buildings, each carrying around 1,500 to 2,000 tons. If they have some vision and foresight, yes, at the end of the 5 years, 10 years, I'm going to have 20,000 tons requirement. Possibly, if they plan it, if they are able to concretize the entire thing, they will definitely optimize, save on infrastructure cost, you know, transformer cost, and so many other electrical structures and water systems and all that. But that's where I think somewhere, and the government also is not possibly, you know, guiding this, but we have taken, ISHRAE has taken the initiative. We have edited the document and contributed a lot of that to BE and made the design guidelines for DCS system. But I think the maturity of the entire owners, somewhere developers, we have to have a lot of interaction with them, a lot of discussions with them on why is it that they are not going for this kind of thing. And only I am seeing in future developers possibly taking into the role of DCS service providers. I think government may not happen. So if you have a big developer, they may possibly invest in a DCS, and any other any other building coming around the area, they should be able to provide chilled water. I think that way we should look into. That's my take on this.
And I want to take this off to Dheeraj, and two questions, Dheeraj. Every time I'm asking you two questions, because you manufacture multiple products, I think you can answer multiple questions also. One is to do with, we hear a lot about renewable energy and captive power generation, you know, and how can that drive efficiency of a project, not just HVAC, but of a project. So one is, firstly, I'm going to ask you your thought process on that particular question. Second is, we talked about district cooling. Subbu touched about a very good point in the end, and I'm going to take it off from there. He talked about developers putting up systems to be then taken forward as a business and sell HVAC consumption to other users. CAS has been trying to come to India. You know, cooling as a service has been trying to come to India. To the best of my knowledge, it's still not been a very great success model. I know a lot of companies are working internationally very big in that. And to bring district cooling in the concept that Subbu brought, it can only work if you start the concept of CAS working in India. So between these two, however you wish to choose and answer whichever one first or second or not, I'm leaving it to you.
Again, you know, you make my task easier, frankly, asking that difficult one to Subbu and then come to me. So I'll pick it up from where Subbu left. Okay. When he spoke about how the design can help you optimize the infrastructure of the HVAC system, he last left it at, you know, even the transformer design can be optimized and the loads can be lower. So I'll pick it up from there in terms of renewables, what you spoke about. It's a very, very interesting thing, but a very, very minute thing if you observe. when you work on a design, which is spread out design, when I say spread out design means, for example, an educational campus, you got 6 different kind of buildings, etc., in spread over a huge campus, and you try and design them separately with individual equipments, then what happens is your diversity is not we are making use of. You are having a standby for virtually every building, what you are designing for with individual systems. But as soon as you move to a district cooling system, you put all of them together, use the best diversity, bring down the peak load. At the same time, your standby also gets reduced to only one with the smallest capacity which you are using in that system, whichever system you are using. I repeat, I'm not a big fan of any particular system, but I'm a big fan of HVAC design and optimization of design. So with that, what it happens is you go back to everything. Your electrical requirements come down, your transformer load comes down, your transformer capacity comes down. And with that, your connected load requirement comes down. Now imagine if this kind of an approach is being used for every greenfield project, and even in retrofits, if you go back and work on the design, how much of load are you reducing from the government shoulders in terms of making available the power requirements from a futuristic aspect of the country? Today, we are working so much on renewables, but still the government says we require a lot of fossil fuel-based plants, which is increasing the carbon footprint for us as a country. Now, if we are able to bring down that demand basis the best possible design and moving to a district cooling, most of the applications, if not all, then imagine the kind of work we are reducing for the government for bringing down first on priority the fossil fuel requirements. The plants requirements come down, and then possibly there comes a day when everything gets met with only the renewables. And that's going to be the best day for us as a country. Our commitment to the world in terms of net zero probably gets fulfilled even faster than what we are committed today. That's the power what we have today with an optimized design and district cooling approach. So I hope I have answered the first question which you asked me. While I was answering, sorry, go ahead.
I'm saying basically you're saying that it's a combination of both generation and consumption. Everything cannot
Absolutely.
depend only on reducing the generation efficiency or increasing the generation efficiency, but we've also got to be able to reduce the consumption or the requirement. So once we reduce the requirement and then obviously take care from a distribution side of the business, from a power distribution, the two together can make a multiple impact than just looking at one aspect.
Absolutely, absolutely. Demand, supply, it's something you are reducing the demand itself.
Okay, fair enough.
Can you repeat the second question, Vishal?
I was talking about CAS, cooling as a service.
Okay. So yes, your observation is right. Despite the best efforts from some of the organizations who have stepped into this as a business, the acceptance is not coming as fast as what we would like it to come. Historically, when we go back and see application-wise, the earlier buildings what we have today, 50% of the application what we used to have as a country lies in commercial buildings. That's where the opportunity for us lies, in particular, when it look at the district cooling piece. I'm not saying other applications don't exist, they do. In last about 5 to 10 years time, we have seen a lot of industrial push being given by the government. So the industrial applications now also have started coming up with a large requirements. And these being large capacity requirements, they are mostly chilled water systems, hardly any DX type of systems or VRF systems. Now there we have to evaluate, and some of the large business houses, including like we have ISHRAE from Reliance and many other such groups, who are also evaluating such things, whether they can go in for a district cooling or not, whether it helps or not. But more importantly, if the developers come forward today and they start looking at CAS as a model, because they would like to deploy their resources and capital into their core business. If they step away from services and give it to somebody who is professional and can do it better for them, they'll be able to put their money where actually they would like to, they would prefer to. So we'll have to see that how, again, I mean, I'm not saying that that's the only way. A private developer should look at this as a good model for them. They should start exploring it more. At the same time, government should try and build policy around that. If somebody picks this up as a business model, they would try to incentivize in some way or taxation in some way, so that there are more and more people coming forward to use this, to evaluate this, and if they find merit in it, why not?
Thank you.
That's something which I want to answer.
Thank you, Dheeraj. But I still feel, CAS is the future and it is going to be here. There are a lot of legislations and financial safety net that needs to be built around it. But to go to the large plants, as you rightly said, I need to do what I am best at. Maybe I'm good doing air conditioning and the other guy is good at running a hospital. He should just bother about running a hospital, not bother about the back end. And then he can do these mega installations, whether it's through district cooling concept or any other concept. So
Absolutely.
it's absolutely coming in over there. And I'm going to go to Kalyan. Ijaz, I'm going to come back to you with a very you can keep your thoughts together. I'm going to come back to you with a difficult question. Kalyan, first to you. A lot of emphasis is paid on design, a lot of emphasis is paid on product selection, the right manufacture, right technology, etc. Somehow, again, since we are both in the same boat as being contracting companies and service providers, the impact, the focus on commissioning, in our country broadly is still understood कि on कर दिया ठंडा हो गया, हवा balance कर दी चलो सब ठीक हो गया, is still not there. Because at the moment, and you're going for larger plants, more complicated systems, commissioning and post-commissioning maintenance. Let's talk of commissioning first right now. Is still not there. Are you seeing that awareness coming in? Are you seeing that people are not taking commissioning the way commissioning is supposed to be looked at?
See, what's happening now is there are only few projects, they talk a separate line item of, tab. That is, otherwise what is happening is there is no balancing as such, water balancing or air balancing or any commissioning procedures or handing over procedures are not being maintained so far. And I see some of the MNCs, we are very particular about the, power consumptions and the energy efficiency systems and all that. So they want the contractors, also the consultants to be part of the energy consumptions, so that they get the correct picture about what is designed and what they have got. So this is something where very few organizations are going into. And the second thing what I find is we don't have a good type of skilled manpower in doing this. There are hardly any agencies in India where you find one in Chennai, one in Mumbai, one in Hyderabad. There are some very few agencies who are doing the tab. Otherwise, there are not many manpower availability. Other than that, there is no proper instruments and equipment used for this particular handing over system. I don't know how many places we really check, except the temperature. We don't check the, CFM or even the fan. What is the fan, how it is working, whether it is working as per the curve, whether you got, the static. Sometimes, most of the time, initially the fan is designed for certain static, and your fan is running with low static, and you get a lot of air sometimes, and you don't get the desired value of temperatures and other things, which, many times it happens. Maybe because of it's not a filter choke condition, it's much more than that. So these are all the things which we find in many places. Basically, my point is most of the projects are happening somehow in time. I don't want to shorten the term, somehow in time. So finally, the last point is the, testing and balancing and handing over. These points are totally faded away. Now, the most of the time, you get the power at the last minute, you get the chiller at the last minute, or you get all these things at the last minute. Somehow the customer wanted to enter the premises and going. I think, and also many times we have, the project is in the drawing board for 3 months and, execution is given for a month. So that is also a problem. And the changes, in India, we have a lot of changes till the last minute, and these things are pushing the project delay. And finally, the last casualty is the commissioning. So this is what is happening.
I'll tell you what, the ISHRAE has done a lot of work on the commissioning, and Ijaz has been part of that team that wrote up a commissioning guidebook. There's a commissioning certification course that ISHRAE runs. We have a few certified professionals in the country today who are, in that field. The main concept of commissioning is it's supposed to be third party. It's not supposed to be a contracting party. And the commissioning agency technically should be on board at the same time as the contracting party and not at the end of the whole project. And it's not happening. It's coming in, but it's like not in 0.0001% of the cases. But I wanted to hear it from you at the horse's mouth that yes, that is a very largely ignored area, and whatever best technology, especially now the systems are becoming larger and larger. If we do not balance them, we do not commission them properly, we're going to be having bigger problems come up. Ijaz, I'm coming to you. It is said, what you can't measure, you can't control, right? And, and again, because it's becoming bigger in scale, So measurements start becoming more important. Now, again, as an owner, as an operator, how do you want a system to be able to measure and verify energy savings from a system design?
So as you said, first the base has to be clear. So I should know what is my energy consumption at the beginning. Current energy consumption of the, and it's not only the component. I always say HVAC is a system. So it is not only the chiller, or it is not only the HU or pumps you're going to get, but I should know what is my HU, what is my pump, what is my FCU, what is my chiller. So I need every component's efficiency or the measurements as well as a holistic system. And for that, BMS is a major thing. And I always find BMS is the last casualty, as you said. It doesn't get commissioned. So first thing, I think as an owner, we should get BMS system in commissioning when the system gets commissioned. So I should have the proper data of this system. Now there are a lot of people now says, I've turned the table, a lot of people comes, change this and you will get better efficiency. You change this component, you get better efficiency. But that's not the way. It is shooting the arrows in different direction. So when we get the basic data available, and if someone says, or if you go for isolated retrofits or even the total retrofits, I know what by stimulation, there are a lot of technologies available right now, what kind of energy saving I can get. And if I go for that, then I make sure that the components which are getting changed or getting retrofitted, they should also get integrated to BMS system. If that doesn't get, my data doesn't come. So once I have the isolated retrofits or total retrofit done, I get a data again from BMS. And then only I can compare the energy efficiency. Otherwise, we are all shooting as I said, missiles in different direction. We don't get anything. So I should have BMS in system. I should get the current data of energy consumption. If I go for retrofit, I should have BMS system working, and that should show me the difference of energy. There are a lot of things like now people are talking about digital twins, where they are saying that they build the digital twin and get the data of your existing system and what better they can do. So digital twins again is gaining momentum, but I don't find, at least in India, many are being done. So that is another way of measuring it. But first, I should know what is my actual baseline from where I can consider the saving or not saving. And for that, I think data plays an important role.
Thanks, Ijaz, and very rightly said that if you do not know where you are, how do you know where you're supposed to go? And Subbu, you are the BMS king. Yeah, I'm not going to be asking you about BMS today. Now, again, in the question today from the audience, a lot of people have asked about artificial intelligence. We are hearing that word all across the whole world in every sphere of our lives, day in, day out. And this question is to you and to Dheeraj, because as a corporate, as a manufacturer, they are also in that field. What role today AI is going to play, specifically in the points or what Ijaz talked about? And is it coming in? Is it coming, or will too many years to go, or what exactly the technology that AI is going to help us in HVAC? You're mute, Subbu, you're mute.
The AI definitely, I think going forward, AI definitely is going to make a big headway. It is going to make a big headway into the operation of our system, HVAC system. AI and machine learning, what they talk about. See, what happens is we have huge data now, and because we know that the load of the building depends on the occupancy, then again fresh air, then if again your fresh air depends on occupancy, then lighting depends on occupancy. So everything is related to that. So which means it is dynamic. Now, even though the system is designed for peak load and your block load and all that stuff, the system should be able to handle the variable part. Basically, how do you conserve your energy? How do you optimize it is your supply and demand. For example, a district cooling system. Your demand for chilled water and supply of chilled water should be same. And demand for chilled water comes from your load side, your AHUs, all that. And that depends on your occupancy. So how can you do that dynamic thing is by AI. Now today, data is, so much of data is there. We can do data crunching. It is possible. It has been demonstrated in some locations. Now, how far it has been done within India. There are some examples which have been happening here within India. So the data crunch is happening within AI. And with that, what happens is, whatever set points we are doing, those are dynamic. Those are not fixed set points. And then again, we talked about the commissioning, where you commission a building when the building is under occupied. Building is not fully occupied. So all your set points, whatever we put it as a HVAC team. Now, I'm not telling contractor, consultant, owner, manufacturer. As a team, whatever we put, based on which all your energy parameters are all defined, which are impacted. Those are all changing, because when the building gets occupied, those set points are a lot different. Now, how do you do that? You have to gather the data. You can analyze the data. And what is happening is, I think the industry, we have to learn this from the data science. There is a hyper automation we are talking about. So your hyper automation is much more than building automation. I think it is going towards in that direction with the data crunching. All the parameters you talk about, for your pressure set point, your duct static pressure set point, your variable pumping pressure set point, your chill water set point, based on occupancy load, ambient load, and all that, it can be done, and it is going to make a big headway on AI and machine learning. I think there are a lot of opportunities. Only thing is, we have to have some proven and demonstrated case studies coming up, and then we have to publish all that. We have to make everybody know. But before we go there, we have to make the basic BMS system work. As I just said, that is the one, one weak link that we have. So I feel that every contractor, every end user, they have to start getting the capabilities on BMS up to speed. They have to enhance that. It should not be left only to a BMS contractor. I think it's not rocket science. Every HVAC contractor should get into this tab and commissioning and BMS. They should get themselves capable. Their capability level should go up. Only then it will be an integrated system. See, today what happens is, somebody supplies chiller, somebody supplies AHU, somebody supplies BMS. Who is tying them together? What it works together? So somebody has to tie up. Now, it's an integrated system. As Dheeraj said, integrated system efficiency, system kilowatt per ton is what we want. Now, if everybody handles each one equipment, who is going to do the system kilowatt per ton? What I am going to get? I think that is where the problem. That may happen is with some customers, end users, who are able to understand. For example, Reliance or Infosys or those kind of customers. But not every builder, every developer doesn't have that kind of capability. I think we have to build that capability, skill set with every contractor. They should not be within their own comfort zone of, I will get chiller, I will install chiller, I will commission, get my money and be there. I will supply pump, I will supply PLC, and I will sit down. I think it should stop somewhere. I think we should move.
I know. Very valid. Very, very valid. Dheeraj, going to you. One is follow-up. Second is a very dangerous question. Subbu won't like me. That's why I'm not asking him. You think AI is also going to start getting building designs, HVAC designs, and throwing up multiple options? Because as Subbu said, and you all said, there's so much data available today.
Absolutely. Before I answer that question, again, Vishal, I just want to thank you, for asking questions, Subbu to first and then come to me. Subbu makes my task so much easier, frankly speaking. The last question which you asked, Subbu, that who brings everybody together, who brings every services together within the HVAC plant? I bring it together. That's what I can tell you at the moment, because we have got such systems today from manufacturers, not just, when I say I, means from all manufacturer fraternity, frankly speaking, that we've got systems in place which are called, plant optimizers, not plant managers, which manage only chiller, but plant optimizers, which can pull every equipment inside the plant room together, pull out all the data. And we have done some good work around this in the retrofit jobs also, not only just in greenfield, but brownfield as well. We have got at least about 30 to 40 proof of concepts when we gave a commitment on energy consumption, kilowatt per ton kinds. And we have stood up to that commitment. Professional customers are very happy with them. And they are saying that we would like to repeat this. And we've got many repeat customers. So I am actually waiting for the day, Subbu, that when we start asking for a kilowatt per ton in our design from consultants, challenging manufacturers, rather than picking up, I want screw chiller, air-cooled, water-cooled, centrifugal, or magnetic levitation, or ceramic bearing, whatever. Instead of that, you say that I want a kilowatt per ton in my plant room, so-and-so. What is it that that Kalyan can give? then
So
Kalyan
a performance-based design rather than just
absolutely
my requirement.
Absolutely. And we are ready for that. Give us that opportunity. We are ready for that. Now, coming back, is it going to impact the design also? Today, we have got software, Vishal, with us, wherein you can actually look at all the options in front of you, and you can pick and put all the data basis either your experience or your design assumptions. And then you get an output saying that this is the design what you get in terms of alternatives, air-cooled, water-cooled, VRF, DX, whatever you want to put, you put. Not only that gives you the complete landscape of design options, but also gives you a complete cost of ownership, including CAPEX, OPEX, and also including some of the output as carbon footprint, which is a part of your ESG goal at times, as Ijaz had pointed out. So you have that kind of software available, give us that opportunity, and many other manufacturers have it today. That's what I believe. And we can give you a design. I saw one of the questions also in the panel over there that somebody asked that how do we choose a good system? You don't have to work that much. Only what you require is assumptions or actual data. Put that in it and you get options. So hope I answered the question you asked.
Oh, absolutely right. And there was one more follow-up question in the chat box. Very interesting question, very simple question, but actually escapes is that why isn't data out there in public domain? Why isn't data available to everybody? Why is it limited to only either the owner of that property or the owner or the manufacturer of that equipment? Why isn't data there of typical case studies, of typical examples, which becomes as the input? And as Ijaz, Subbu rightly said, more the data, more the accuracy.
So
why
can I answer that?
Anyone?
Can I answer?
These are not all common questions.
Okay. The answer to that is that when we do such a work with any of the customers, any of the clients, we sign an NDA with them. The client does not want this data to be made public. So we cannot, as manufacturer or as somebody who works with the customer, I cannot share the data unless I'm allowed to. So there is one such case study available in public domain, which we also share with everyone. I can share it now also. We did some work for the DLF corporate building and they spoke about it in open. That's available in public domain also, that they saved so much of power, which is close to about an ROI of close to about 3 years is what they got when we did that work for them. So anybody can go and have a look at that. There's another study which was done by Taj Hotel. We worked for them also. They got an ROI of less than 1 year, the work which we did in terms of the energy savings, what they wanted. And post that, they've been saving energy consistently. So that is also available in the public domain. We can share it. I can ask my marketing team to share it with the ISHRAE platform, and then you can circulate it if the need be. But not every customer we can do it because the customer doesn't want data privacy is something which you have to uphold.
Okay, so I have one. Subbu, you want to say something?
Yeah, see, I think what happens is, I think, Vishal, it will be very nice if we start having, sales engineer, design project engineer, system engineer, I think we should have somebody like HVAC system engineer. I will only talk about system. I think that should happen somewhere on the line.
Fair enough. Last question, which is open to any one of you who wants to take it up. What change you want to see in the code, standards, government regulations as they are today to encourage people to go in, especially for the large plants, to be able to go in for these really high efficient system designs, if at all anything?
I think we are reaching to saturation level in terms of EOPs of the systems. Now the most important aspect is how do we implement it, and there is a major challenge there. How do we implement? How we commission? If there is going to be some push, and there is not only the code, but there is some follow-up, where whether the codes are getting followed, it's just on the paper. I think that should bring in some, you can say, some rule about whether the code get implemented or not. There should be some third-party review, and if it's not, then there should be some penal action. Otherwise, as Indians, we are all here to break the law, all the laws, and that's the system. Because codes will be written. We have gone to an extent where I don't know what COP will reach, but any system will have some inefficiency. So at what level we can go? We have to now focus on implementation aspect. We have to focus on how do we commission the system. And if we don't do that,
two aspects. One is the till commissioning, what we're doing in system. What about if anybody wants to touch upon Kalyan or Dheeraj or Subbu, anyone talking about 2, 3, 4, 5 years down the line? What was originally conceived? What was originally installed? Has it been maintained to ensure that I'm getting the same outputs 5 years, 6 years down the line, what I had committed in the code?
Yeah, I think that's what Vishal should happen. I think every building should have design efficiency, design system kilowatt per ton, and what is the operating live system kilowatt per ton, what is happening. Because both are, this is very important because we are talking about decarbonization, net zero, and so much.
Is that happening today? Is there a system that today I got rated as a X? I'm not going to name any agencies or any certification. I'm rated as X today. 5 years down the line, is there a way of live monitoring it to ensure that I am maintained my X or within the tolerance limits? Is there anything happening today? Dheeraj, you want to say something?
Yeah, we do, as I said, we do have plant optimizers in place, which can give you an entire live coverage of the plant room at any point of time. All equipments can be seen, their performance can be seen, their status can be seen, and you can compare that with the design parameters at which you design. At any point of time, if you find and see that there is a variation or deviation from what you designed it for, away from the performance what you had anticipated basis the assumption of parameters, then you actually can go down to the level wherein you can start looking at what kind of a maintenance do we require to bring it back to where it should be. Not only that, but at times, it is operating well, but certain parameters go off. So predictive maintenance also helps you in making sure that the plant doesn't go down at any point of time. So breakdowns can be prevented. So that's the level where we can actually go down to. That kind of technology is today available and people are using it as well. We have done some good work around where people have been able to look at this data, connect back with us and our call centers, and we have acted with them proactively, preventing those breakdowns and even the cost attached to those breakdowns, and the customer has got benefited. So that system is available. Question is our adoption rate, which is very low today as a country. Question is consistency of using of the technology because of, I will say, lack of trained manpower. If we can work around that as all of us coming together as an HVAC community and see that not everything can be done by government. We also have got responsibility on our shoulders. Can we all come together to see that we create more awareness? We have more people who learn about this, who've got knowledge and skill around this, and we can probably change some bit of it, if not all.
Thanks, Dheeraj. Kalyan, you want to add something?
See, my only point here is we are talking about COP efficiency and all that fine. Initially, you give a better COP mission, better efficiency mission, and finally it is not maintained and it is not going to give the same efficiency or the same COP what it is going to give. So I would say, there should be a system where you measure the power versus the usage and what is that they've used and what is the power. Even, like how all of fame is being done in ISHRAE, it can be started from ISHRAE, then it has to be taken to the government where the least, highest efficiency, not only a system, including the maintenance. It has to be maintained and the power consumption has to be at the lowest. So that kind of a system should be identified and it has to be, recognized. I think that will give a better way of sense. Because, we all good at designing a best efficiency system, but very poor in maintaining the system. So this is something which throughout the year, what is the level of, power consumption you got for the whole system and what is the periodic maintenance you have done and how the efficiency is still maintained at the same level. That is more important to, look at. That is what my submission.
Fair enough, Kalyan. Very valid point. Ijaz, I think you wanted to add something.
I think this rating certification, which is given by the lead or anything, platinum, green, this should have a period, maybe 2 years valid, and it has to be validated again and again. Otherwise, that pressure will not come. If it is rated once, that building becomes platinum forever. It cannot happen unless we revalidate it after a couple of years. Some period, like some certification, personal certification, we have to revalidate ourselves. So unless that happens, I think the pressure won't come.
Yes, it is valid for the initial thing is valid for 5 years. After that, it is renewable every year. There is for example, lead. I'm saying lead arc. It's a dynamic value which comes on energy, water, indoor air quality, human comfort, and human experience, transportation, all that. It's a dynamic one.
Fair enough. I think we've already overshot the time. I think we could have taken this discussion and continued for as long as possible, being such an interesting topic. And we At times we did deviate exactly from the subject of the matter, but then the point is that large or small, some of these points remain common, irrespective of whether it's AI or monitoring, measurement, code, standards. So from my side, a big thanks to all of you. Subbu, especially as a consultant, thank you very much for throwing your insights both from a design perspective as well as from an automation and AI. Dheeraj, the amount of technology, the products, the solutions that are available today out there in the market, many people are still not aware of it, are still not using it. I think a lot of it is to do with the lack of awareness rather than the costings of that, because we know that times they're not very high on cost, but people are not aware that such things are available in the market. So I think we need to do a lot more as industry together to ensure that people know about the things available in the market. Ijaz, again, wearing the client's hat, you've also been a contractor, so you have both the hats, but today as a client's hat as to, what is a user looking at, and you made very clear that measurement for you is actually paramount, baseline, and where we are today, just paper design does not make a difference. So thank you very much for that. Kalyan, thank you for wearing the contractor's hat. Thank you for bringing out this manpower challenge, which we are all aware of. And it's only going to become worse in days ahead unless until all of us do something drastically and urgently about it. We are all trying, but yet very, very baby steps. So from my side, a big thanks to all four of you. And over to you, Mani.
Thank you. Thank you, Vishal.
Right,
Thank you,
sir.
Vishal.
So good evening, and thanks to all the panelists and moderators, especially for sparing your valuable time and sharing the valuable and insightful information to all the participants who all have attended today. So this panel discussion, I'm sure it was great and wonderful, wherein we all got a very deep insight about the industry highlights and how we can take it forward, like integration of AI and district cooling and many other innovative concepts in the future in this HVAC and building industry. So thanks to our society president-elect, Mr. Janta Kumar Das, for sparing your valuable time, and the ISHRAE staff, Ravi and Neetu. Thanks to all, and thanks to all the participants, because we all were gone more than 200 participants today in this panel discussion. And this have become one of the biggest online panel discussion under the ISHRAE Technical Committee program. So thanks to each and every one of you for sparing your valuable time, and keep in touch for upcoming programs that we are organizing under the ISHRAE Technical Committee. Thank you very much to each and every one of you.
Thank you. Bye-bye.
Thank you. Thank
Bye.
you.
Thank you.
Thank you. Thank you. Bye-bye.